start tuning the Random Forest Classifier model, let's also set this one for 8.3 so we can refer. So we are done from tuning and finding the logistic regression model based on the randomized search CV. Let's add just a text here, just to keep everything organized and neat. Classifier model with scikit-learn using randomized search CV. Let's set this into bold. Also shift enter. So just to recall what is randomized search CV method that we're gonna again use for to tune the random forest classifier model. It's a method from the scikit-learn model selection module that it perform a random search over the hyperparameters combinations to find the best model configuration or parameters. It's useful for hyperparameter tuning where you want to search through a range of different hyperparameter values for an estimator, such as the classifier or regressor, to find the set of parameters that yields the best model performance. To do that, we'll type now random forest classifier hyper tuning, or let's call it hyperparameters tuning. To do that, we'll do the same thing first. We'll set the random seed to ensure the reproducibility of the results, so you don't get different results than mine. That's why we set it into. And then let's set up a random search for the random to do that, we'll use the RF. We'll choose the model noise search. Okay, it's here, CV. Then we'll choose the random. So we chose how we're gonna train the model using which method randomized search CV, and then let's choose the model forest classifier. Let's set the RAM distribution. RAM distribution equal to RF grid. We'll also go with cross validation equal to 5 folds, and as well as the number of iterations equal to 20. Equal to true. Let's now fit the model. Random search model for to do that. We're just gonna use the rs dot fit method. We'll take again our training data, the xtrain and ytrain datasets. We run this code and then we'll discuss each of the codes so you can make it clear. As you could see now here, it's fitting the model and it's processing. It might take a minute or two. So let's discuss exactly what we have done in this code. So as you could see that it has fitting the 5 folds to each 20 candidates, totaling around 100 fit. So first we set the random seed, as we have mentioned many times, to ensure the reproducibility of the results. This ensures that the random selection and the random search, like sampling hyperparameter, are consistent and across different runs. And then we've set the RF grid we have here. It's different from the parameter distribution for the logistic regression model. If you recall our set it to log. If you recall, these were the hyperparameters that we set. So now we are using the RF grid, the best parameters. So this code will go through all of these configuration of the model and we'll find the best parameter using the search randomized search CV. It's still loading. So the RF grid, you need to define the RF grid which specify the range of values for the hyperparameter that randomized search CV will search through, that we have set it as I mentioned earlier here. As you could see it. And then also we have fit the model using the training data, using the fit function to perform the search. Now after that we have completed, fitting our model to the training dataset. Let's find the best hyperparameters were found. You can also, click here. But in case if maybe you are using like a Jupyter notebook, you might not have the same results here. That's something good about the Google Colab. As you could see that it has found the best settings or configuration for the model. So like the max depth is equal to 3 million samples that we have discussed before, what each of these means. So these, you can consider them as the best hyperparameter for the random forest classifier. But let's also